Hey, pre-calculus. Today we're going to be going over Handout 10, and in Handout 10 we're going to talk about the sine and the cosine function. And so first we're going to start off by looking at the sine, and we want to look at the sine function so that y equals sine theta. Right, so anytime we plug in sine theta, the output is always going to be the y coordinate on the unit circle. So in other words, when we look at the unit circle, we have a unit circle, and as it's playing through, you can see this line starting to appear as we're going right here. And this line right here, that is the y coordinate corresponds to the y coordinate of the unit circle, and the x correlates to the angle that we're at on the unit circle. So you can see how it's tracing everything out as we go through, and I will be leaving this interactive demo for you to play with under the folder for this handout. Alright, so back to the handout in question, handout 10. We are again going to be looking at the y values from the previous handout. Which previous handout we're talking about? We're talking about handout 9. And so here's our unit circle right here, and we're going to be looking at all of the y values. That is, the sine theta. As we saw right here, y is sine of that particular angle. So going back to our handout here, note that the y values only go between the following values. Now, y can be 0, y can be, and then the next value it comes across is 1/2, and then root 2 over 2. And then root 3 over 2 going here. And then, of course, right there, we have a value of 1. So these are all the values it goes through in the positive end and the negative end. Of course, it's the same thing, just a negative sign in front. And so let me zoom in a little bit more, make sure I have enough space. Negative 1/2. Negative root 2 over 2. Negative root 3 over 2, and then negative 1. So as you call from the unit circle, when the angle is 0, the y has a coordinate of 0 as well, so it goes right there. And then we roll forward with the unit onto the unit circle, as we come across this next angle, and this angle is pi over 6. When we get to pi over 6, we are at root 2 over 2. And then the next angle we come across is pi over 4, and that ascends up to here. And then the next angle we come across is pi over 3, and which brings us up to here, root 3 over 2. And then finally we get to pi over 2. That is a 90-degree angle, which brings us to a sine value of positive 1. Alright, and then you keep circling down as you go through the next ones. This one is 2 pi over 3, putting us at root 3 over 2. Next guy we have is 3 pi over 4, putting us at root 2 over 2. And then the next angle we have 5 pi over 6, and that puts us at 1/2. And then finally we go a full 180 degrees. That is pi radians, which brings us right back down to 0. Okay? So now we keep moving forward. Now we're at 7 pi over 6. And that puts us down here at a negative 1/2. Make sure you're following along on the unit circle to make sure that all these numbers make sense. And then the next guy we come across is 5 pi over 4. And we go down to negative root 2 over 2. Next guy we come across, we are at 4 pi over 3. Putting us at negative root 3 over 2 down here. And then finally we're at 3 pi over 2. And that is the equivalent of 270 degrees, 3/4 of a rotation. And that puts us down here at negative 1. And just remember, in the unit circle. And so you can see when you're going all the way down to here, we're at 3 pi over 2, and we're pointing straight down. And so here we have it, 3 pi over 2, and that puts us, wrong spot, 3 pi over 2 down here at negative 1. And then we continue the pattern again. This time we are at 5 pi over 6, putting us right here. And then right here, we are at 7 pi over 4, putting us right there at negative root 2 over 2. And then on the next one, we are at 11 pi over 6, and that brings us up to negative 1/2, and then of course you go a full 2 pi, and that's going to bring you right to there. Alright, and if you were to keep going, the next one right here, that's going to be 2 pi plus pi over 6 right here. And so that just brings you up to 1/2. So let's go ahead and fill these. These are all still equally spaced. This is negative pi over 6, brings us to negative 1/2. And then again, this would be negative pi over 4, bringing us down to here. What these negative numbers mean is that we are rotating in the opposite direction we were before. We are rotating clockwise instead of anti-clockwise like we were a moment before. And so let's go ahead and connect all these dots like so. And so we see the sine graph appearing before our very eyes. Cool. Any questions there? I'm sorry, that was a habit. So let's go on to the next part where we have f of theta minus h, where h naught is simply a shift to the right h naught units. And so here it says to graph sine of sine of theta minus pi over 2. Right? And so what is this pi over 2? Well, that is simply our horizontal shift. Everything is being shifted to the right pi over 2 units. So let's go ahead and take a look at this. Ordinarily, you'd plug in what is sine of 0, but we're not plugging in 0, we're plugging 0 minus pi over 2. And so this would be sine of negative pi over 2 whenever the guy is pointing straight down. And so our line would go right here. Oh. Right here. Okay. And then we'll kind of just pick out some of the key points here. When we plug in right here, ordinarily this would be pi over 2. But, we're plugging in pi over 2 minus pi over 2, so we say, what is sine of 0 at this point? And so that's simply right there. And so note that this point is corresponding with this point right there. Everything's being shifted over to the right. So let's go ahead and fill in all the in-between points. Okay. And right here. Very good, and we keep going. Alright, and then once again we connect all the dots. And we get this guy right there. Again, note that everything up in the top is being shifted to the right by a distance of pi over 2. We kind of go ahead and hit all those key moments right there. Alright. So that's a good illustration of what's going on there. Let's go ahead and connect those as well while we're at it. Alright, now it's time to remind ourselves of another guy, the B factor that we have here. Note that the B factor tells us how much we either stretch or shrink. And it's going to be a factor of not B, but 1 divided by B. So over here, the stretch shrink factor is not 2, it's going to be 1/2. So basically we're going to be taking this guy here, and everything's going to be happening in quicker succession. It's going to be happening according to the scale. And you notice I've already shrunk the scale down by 1/2 for convenience sake. So let's go ahead and just fill in all the points. Alright, so sign of 0 is always 0. And then, we'll go to pi over 6. It happens a little bit sooner here. Alright. So we're noticing that as we graph this, all the points are happening a lot faster than they would normally. Okay, there we go. So let's go ahead and connect all these dots then. Along and straight up. There we go. Alright, so kind of look at the first graph and the second graph here. And kind of imagine that this graph represented the surface of the ocean as a wave goes across. In this first one you can see that the wave comes by kind of gently. You might be sitting on your surfboard and you gently go up and you bob down. Down here in the second one, notice how much more quickly the waves come by. So imagine you're on your surfboard and now you're getting bobbed up and down kind of with a lot quicker succession than you would from the first wave. And we can and do model ocean waves with these trig functions. Okay, so we've gone over how the sine wave is generated up here. We looked at a function shift right here, and we've looked at how this moves around. Let's talk a little bit about the period of a sine wave. The period is how long it takes for the entire pattern to go through. And we've noticed that with sine, that period is typically 2 pi. Right? 2 pi is how long it takes for us to begin the pattern like you see here, and then for us to end the pattern right there. And we go through some of the same points in between, but it's the overall pattern that has to be repeated. And so note that down here the period happens a little bit more quickly. We've got this B factor and right here. Notice how the period, it's a measure of the length, right, along here. So what's going on is that the period length actually got shortened. So to calculate the period length in general, you have 2 pi divided by b, where b is always that number in front of theta right there. So in general, the format for a sine function is going to look like this. y equals some big A right there times sine of b times theta minus, whatever our horizontal shift is. It's typically called a phase shift when we're talking about trig functions. And then plus k naught, where k naught is our vertical shift, just as it always is. So I encourage you to just plug this whole thing into equation into Desmos, leave the a, b, h, and k as constants and play around with those and see what happens. The amplitude, that's the a value, that tells us how big our troughs are for the wave, how high the wave's going to go, how low the wave's going to go, about this line right there. Okay, so let's look at the cosine function now. And the cosine's basically going to be the same as we did for the sine, except that the cosine is going to be the x coordinate of the unit circle. And so we go through this, and these are all going to have the same values as they did before. And then, of course, on the negative side, the clockwise rotation, we have negative pi over 6 here and negative pi over 4. Okay, so we've got all the angles filled in here. And then the y-axis, again, is going to stand for the x coordinates of the unit circle at a given angle. All given right here. And, of course, they would repeat down here. Negative 1/2, negative root 2 over 2, negative root 3 over 2, and then finally negative 1. So again, note that all the x values are the same as the y values on the unit circle. Alright, so cosine of 0. What is cosine of 0? If you refer to your unit circle, you see that the x-coordinate when the angle is 0 is going to be positive 1. And then at pi over 6, it's going to be root 3 over 2. And then root 2 over 2. And so on and so forth. Verify all of these on your unit circle. Pause the video and do that as we're going through these. Make sure that there is a solid connection in your mind between this graph and the unit circle. And we just kind of keep going down the line, and you should be looking at your unit circle to make sure that all of these correlate. And we get to 7 pi over 6, come back up. Here we go. There we go. And we note that the pattern is going to begin repeating itself once we get up to 2 pi. Right there, and here's the next one right there. Okay. And then these next guys. Again, verify these two as well on the unit circle as well. Again, that is when you go clockwise instead of the typical counterclockwise. Alright, so connect all the dots as best we can. And here we go. And so again, note that we see some of the same values repeated, but that doesn't mean we've completed an entire pattern. One whole period length, that is the time it takes for the pattern to repeat itself, it's given right there. Note that length. That length is our period length, and that is 2 pi. Okay, so the next one, note that function shifts behave just like they do with cosine as they do for everything else. We have a shift of h naught. That means that we have an h naught units to the right. So we can just look at this graph that we've done up here and just shift everything to the right, pi over 2 units. So once again, we're at 0, and we're 0 minus pi over 2, so it's really cosine of negative pi over 2 going here, which of course starts us off at 0. And let's go ahead and take a look at the unit circle, make sure you can see what's going on. So again, we're starting from this angle down here. That's an angle of negative pi over 2. And then we're going to be swinging across this way, like so. All right. And so we note that we'll be going in the positive direction here as we swing forward. So basically it just looks like this. And note up here at the top, this point got shifted to right there. Shifted to the right, pi over 2 units. And so let's keep going on with this. Alright, so we get these points, and I sincerely hope you are working this out on your own, not just watching the video. There really is something to be said about drawing these out to really help you understand what's going on. So now we just go ahead and connect these dots. And so we have this right there. And so, this we'll go ahead and highlight the same portion that we did before. Note that how this all got shifted to the right, pi over 2 units, just as we were anticipating. All right, so let's go on to the next one. Again, this deals with the stretch or shrink factor. Stretching and shrinking works just the same way here as it does with all the other functions we've seen before. With a b's in front, it's going to stretch or shrink by a factor of 1 over b. Alright, so graph cosine 2 theta. Well, the period, which is normally 2 pi, we're going to be dividing by b, that number in front, so that the period in this case is going to be simply pi. So the period is going to have a length of pi. Alright, and so note that we've shrunk this down. It's all being shrunk by a factor of 1/2. The period that was ordinarily 2 pi now only takes 1 pi to go through one full period. And so note, just look up here where it's going to repeat this pattern, but everything's being shrunk down by a factor of 1/2. So we come over here, note that we still start at 0, and we're going to, at 0, we're going to have a 1, sorry, misspoke, and then it's going to start coming down as it did before. Alright, and now that we got all these dots plotted, let's go ahead and connect all the dots so that we can kind of see our nice graph start to take shape here. And there we go, then here. Alright, didn't quite go down low enough there. There we go, I feel better about that. Alright, so again, note that it looks like the original one, but now everything's happening a lot sooner. The starting point was the same here, but note how quickly we go through one full period. It does indeed take half the time. And so for all of our function moving around put together, what does that look like? Well, just like everything else that we've done, y equals the amplitude. Note the amplitude is nothing more than the vertical stretch times the cosine of b times theta minus h naught. H naught is the phase shift, or just the horizontal shift, and then plus k naught, which shifts everything up and down. Alright, well that's it. That's the cosine. Do practice with this in Desmos with the constants. I'll go ahead and put embed a little graph for you to play with there to get a better feel for it. If you have any questions, do not hesitate to email.